Okay, students, we're going to look at several examples, and the first one's number problem, and this is example one in your lesson. We're just going to get right to it. Here's the question. The sum of 4 times a larger integer and 5 times a smaller integer is 7. When twice the smaller integer is subtracted from 3 times the larger, the result is 11. Find the integers. So let's take that a moment at a time. We call L the larger and S the smaller. We could like make a little box here where we're going to put our answers. Now go back to the language. The sum of 4 times the larger and 5 times the smaller is 7. And when twice the smaller is subtracted from 3 times the larger, the result is 11. Notice here my system of two linear equations. So what I did is I rewrote my system, and I realized that I'm going to have to multiply to get rid of one of my variables. I'm wanting to get rid of the s. So I multiply the top equation by 2. That gives me 8L plus 10S is equal to 14. So that gave me this red equation here. I multiply the bottom equation by 5. When I do that, I get 15L minus 10S is equal to 55. What I do is I add these together. 23L is 69, and I divide by 23, and I get 3. So that tells me that L, the larger number, is the integer 3. I need to be able to find the smaller integer. I need to go back to one of my equations at the top, the original relationship, and find that. Now I picked the bottom one because it looked a little easier. So over here, 3L minus 2S is equal to 11. I substituted this 3 in for L, and I ended up with this equation right here, which solves to negative 1. So that tells me that the smaller integer is negative 1, and it is further to the left on the number line. Now the question is, could I check this? Well, yes, I could put them both back into the original equations. Well, since I just used the bottom equation, I'll check in the upper one. 4 times the larger, that would be 4 times 3, plus 5 times the smaller, that would be negative 1, is 7. Is that true? What is 4 times 3? That's 12. What is minus 5? 12 minus 5 is 7. It is 7, so it works out. So that makes that true. That would be how to solve a number problem. Okay, I want to take a second and remind us, in that last problem, I read the problem, I came up with the plan, I solved it, and I checked it. Now, yeah, I did look at this problem a little ahead of time to make this video so that, I came across like I, worked it through. Well, guess what? We don't always have that experience. We don't always have time in life here to, have all the answers ahead of time. So I have learned in doing these problems through the years, you need basically 3 things. You need to be able to concentrate, you need to be able to keep your focus, and endure to the end. If you think about current culture in America, with all of our distractions, we are having a hard time doing all 3 of these things. And so when a student says, I found this hard, I found this difficult, that is not a measure of someone's intelligence. It really is saying, wow, I didn't realize I had this much difficulty. And this, my friend, is a good example of how this class can help you. And it will help you if you don't get upset, if you don't, just get mad when you have a little trouble. And you know what? We all do. We all get frustrated. But if you would work on your endurance and keep at it, it's going to help you to be a better student. This is example 3 in your reading. It's a coin problem. So let me show you how I do this problem. The problem says I have nickels and dimes, and I have a total of 58 coins. If I count up my money is $4.20. The question is, how many nickels and how many dimes do I have? That's a very good question. So let's call N nickel and D dime. Now keep in mind, this N is standing for the number of nickels. D is standing for the number of dimes. You could write that over here if you wanted to. Okay, so that's where you're going to put your answers when you're done. Now hold the phone for a second. A nickel is 5 cents and a dime is 10 cents, right? Also, it says we have $4.20. If I exchange that for pennies, wouldn't that be 420 pennies? Okay. So this is what I'm talking about concentrating and enduring. All right, so the first one says the total number of coins is 58. So N plus D is equal to 58. Also, it says that the total amount of money is 420. Well, 5 cents times N, which represents the number of nickels, plus 10D is equal to 420. Notice now we have a system of linear equations. If you've worked some of the problems up to now, you realize there's different strategies here. Number one, we don't want to graph it. Number two, we could do substitution, but let's look at this. I notice in the second equation, I could divide everybody by 5. Okay? Now, if you're looking for one method that's going to do all of the problems, you're going to be very upset. But just keep on working and you'll get better at this. So this is N plus 2D is equal to, well, that goes into there, let's see, 8, 80, 84. Now, notice my two equations, this one and this one. You know what? If I multiplied that top one by a -1 and put it down here, I'd have negative N minus D is equal to negative 58. Could we use the elimination strategy? Yes. The N's go away. 2D minus D is D. And this is going to be, well, 30, no, 20, 26. D is 26. Now remember, the total is 58. And if the dimes are 26, then the nickels have to be 30, 32. Now, can we check it to see if it's true? Now, just think about this. If I had 26 dimes, that's $2.60. If I had 32 nickels, well, 2 nickels make a dime, so that's really 16 dimes. That would be $1.60. Okay, let's add those together. 60, that's $1.20. Yeah, $4.20. So that would be a way to work that problem. All right, here we have a mixture problem. This is example 5. If you need another explanation on this or see how I do this, here we go. I'm going to try to show you 2 ways to do this. The first one is, let's set it up as a system of equations. 80% antifreeze concentrate is to be mixed with water to produce a 48-liter mixture containing 25% antifreeze. How much water and antifreeze concentration is needed? Okay, I have learned to make a little visual, and this will help you. So 80% of antifreeze, so 80% of X, and is added to water. Now water has no antifreeze in it, so it would be 0%. And we want a solution that is 25%. Now what is this value here? Well, this value here is X plus Y. Now they tell you, well, we don't know that, do we? No, we need 48 liters. That's what we need, okay, to produce a 48-liter mixture. Can I come up with a system of equations? Well, let's see. I know one thing. I know that X plus Y is equal to 48. And I also know that 80% of X, or 0.8x plus 0.0, right, or 0, let's just say 0, y is equal to 0.25 times 48. The easiest way to understand this is as if you had salt, and this solution was 80% salt, so if I dried out all the water, I'd have my salt there. This is pure water, no salt, and this is 25% salt. Okay, so if I dried out this final container, it would have 25% of it as salt, but it would be the same salt I had over here. All right, let's look at this here. This is really 0.8x is equal to, now that's a fourth of that really, right, which is 12. Let's divide that by 0.8. X is equal to 12 divided by 0.8. 12 divided by 0.8. How about 12 divided by 8 over 10, which is 4 over 5? Okay, that's 12 times 5 over 4. That's 3, that's 15. A little convoluted, but x is 15. So what is this saying? This is saying that 15 liters of the 80% solution must add water to get to the 48. Well, so if we're adding y here, and I need 48 altogether, that would have to be 33. So in that mixture problem, I could have, you notice I could have substituted this x as 15 in for here, and I could have just solved for y there. I just did it visually by looking at that problem. I may do another video on mixture problems if you need to, but that is one way you could solve that problem. All right, we're looking at example 6 here. Let me just read the problem. An executive traveled a total of 4 hours and 875 miles by car and by plane. Driving to the airport by car, she traveled 50 miles per hour. In the air, the plane averaged 320 miles per hour. How long did it take her to drive to the airport? Now, you may confuse this question with some kind of, torture, in an enemy camp. And I do understand that, but we got to endure. We got to concentrate and focus. So let's see if we could look at this problem. Okay, this is a challenge. Now, one thing we do know that the total distances are 875 miles in the total time. Now remember, time is distance divided by rate. Okay, so the time for the driving by the car and the time for flying by the plane should add up to 4 hours. And the total distance driving by the car and flying by the plane together should be 875. Now, okay, I'm calling that x. So x plus y is 4. Now, what would be the distance? Well, it's the rate times the time. So 50x plus 320y is going to be equal to 875. We could make this smaller by dividing here. That's a possibility. We could just solve this one for x. X is equal to 4 minus y, and plug in here 50 times 4 minus y plus 320y is equal to 875. Okay, so what I did is I substituted that in, I multiplied it out. 270y is equal to 675, y is 2.5, and x is 1.5. Remember, they're times, so they're hours. Question, how long did it take to get to the airport? That would be the x, which is 1.5 hours. Now, it's tough, but you got to kind of dig down and try to work through it.